Hello students, in this lesson let us study about the aircraft characteristics and the influence of these characteristics on the airport planning. There are totally 13 characteristics which we have to study. So to get started with, these are the 13 characteristics of the aircraft which we have to study before we start the airport planning, or that will affect your airport planning. So the first one is the aircraft capacity, second is the aircraft speed, third is the aircraft weight and the wheel arrangement, fourth one is the fuel spilling, fifth is the jet blast, sixth is the minimum circling radius, seventh is the minimum turning radius, eighth one is the noise, ninth one is the range, 10th one is the size of the aircraft, 11th is the takeoff and landing distances, 12th one is the air propulsion, and the 13th one is the tire pressure and contact area. So let us discuss one by one each one of them. The first one is your aircraft capacity, right? So the capacity of the aircraft will determine the number of passengers, right? So number of passengers, your baggage, whatever baggage is there, that, then cargos and fuel. Based on this, we will determine the capacity of the aircraft. So normally what will happen is the terminal facility will be planned in such a way that it will receive the aircraft at the highest capacity which will be likely to be landed, right? So what are all those? Passengers, your baggages, your cargos, and whatever fuel has to go into the aircraft, that will come under your aircraft capacity. Next, moving on to the second one is your aircraft speed. This is a very important property, right? So aircraft speed can be seen in many ways, or it can be calculated in many ways, but there are two which are very important through which your aircraft speed can be determined. The first one is your air speed, and the second one is your ground speed. So air speed is nothing but the speed of the aircraft relative to the medium in which it is traveling. Very important, right? What is it? Speed of aircraft relative to the medium in which it is traveling, right? If you see, so this is your reference, this is your airspeed, this is how your wind speed is coming, this is your velocity, this is the total in air your aircraft is traveling. Okay, right? The next one is your ground speed, the speed of the aircraft in the ground. So normally your wind speed will be the difference of the air speed and the ground speed. So first let us see more detail about it. So your ground speed is also called as your cruising speed. Now this will be a constant or a fixed speed which is relative to the ground. So name itself is indicating this is relative to ground. If you want to understand more in a more simpler way, if we take an example, suppose your aircraft is flying at a ground speed of 500 kmph, say. So this is what? This is your ground speed. Okay. The air in which it is moving has a wind speed which is equal to about, say, or wind speed or wind velocity which is equal to about, say, 50 kmph. Now suppose these both are in same direction, your air speed will be 500 plus 50, that becomes 550 kmph. Because they are moving in the same direction, it will get added up. Suppose they are moving in different direction, what will happen? Your air speed will be your 500 minus 50, because they are moving in opposite direction or different direction. So this will be your 50 kmph. So that's the reason it is relative to the medium in which your aircraft is traveling. Okay, normally what will happen is there will be 2% difference between your true and indicated airspeed. Indicated air speed. So the pilot obtains this speed from an airspeed indicator, which are very highly sensitive instruments with respect to the density of air at different altitudes. Okay, so normally we find the indicated speed slightly lesser than your true air speed. Now with the introduction of jet aircraft and very high speed aircraft, the reference datum for speed is often the speed of sound. So the reference what we take for aid speed nowadays is the speed of sound. So after the great Austrian scientist Ernst Mach, the speed of sound is defined as Mach 1. Okay, so speed of sound based on the scientist, it is named as March 1. Okay, so if we take March 2, it is nothing but the double speed of sound. Okay, double speed of sound. So most of the present aircrafts are supersonic, that is they are slower than that of the speed of sound. So these days what we can call jet aircrafts are subsonic, so lesser than March 1. We can take them approximately equal to 0.8 or 0.9 Mach. Whereas many of your military aircrafts, they are supersonic. That is greater than they move at a speed greater than the March 1. That is the sound of speed. Okay, so this is all about your aircraft speed. Moving on to the next character, that is your air weight and the wheel arrangement. Wheel arrangement we have already seen in the previous video how the wheel arrangement happens, like two wheels, one wheel, double wheel arrangement, single wheel arrangement, right? You can go back there and refer for the wheel arrangement. Now we will mainly focus on the discussion of your aircraft weight. So there are so many components of your aircraft, right? Like your fuel, engine, wings, body, payload, vertical tail, horizontal tail. Now all this will sum up and give you the total aircraft weight. Okay, and your capital W, this will act at the CG. W is nothing but the mass of each component into the gravitational acceleration. So it is necessary to understand the components of aircraft which make up its weight during your takeoff and your landing, because weight is one of the major factor that will govern the length and thickness of the runway. How much runway should be there, how much length should be there, how much thickness of runway should be there, that will majorly depend upon your aircraft weight. Okay, there are some very important or different weights in your airline operations. Let us see one by one what are these. Right, the first one is your maximum gross takeoff weight. So what is it? This is the maximum load which the aircraft is certified to carry during takeoff, and the airport payments are normally designed for this load. Okay, so max load which is certified for the aircraft during its takeoff. Normally the payment design or the airport payment design is done based on this particular weight. Okay, next moving on to the second one. The second one is your maximum structural landing weight. First one is what? Maximum gross takeoff weight, and the second one is your maximum structural landing weight. Now this is the difference between the gross takeoff weight and the weight of the fuel that is consumed during the trip. Okay, so difference between max gross takeoff weight and the fuel consumed during the trip. Okay, so the main gear of the aircraft is designed to support this maximum structural weight, because such situations rarely occur. For instance, say if an aircraft starts trouble immediately after the takeoff, the pilot has to carefully return the aircraft to the airport, and it should be so manipulated that the maximum landing weight is not exceeded. Okay, moving on to the third one. The third one is your operating empty weight. Now, what is this? This is the weight of the aircraft, which is including crew and all the necessary gear required for the flight. Okay, it does not include your payload and the fuel. So what all it includes? It includes crew plus all necessary gears. Right, it does not include what? Does not include the payload and fuel. Very important. For passenger aircraft, the operating empty weight shall not be constant because it will depend upon how the seating arrangements have happened. Then, now what is payload in this? What is this payload in this? The term payload is used to mean the total revenue producing load. So, the load which is giving you the revenue, like your baggage, your passengers, right? They are giving revenue, right? So, the total revenue producing load is nothing but the payload. It includes the weight of passenger, their baggages, mails and cargoes. Understood? There's one more important weight, that is your zero fuel weight. Now, what is this? This is the weight above which all additional weight must be fuel, so that when the aircraft is in flight, the bending moment at the junction of the wing and the fuselage do not become excess. So the conclusion can be the aircraft weight is the composition of your operating empty weight and the three variable payloads, trip fuel and fuel reverse. Whereas the weight of an airport on landing is composed of what? The operating empty weight, the payload and the fuel reserve. The trip fuel will not be included here. Normally, your landing weight should not exceed the minimum structural landing weight of the aircraft. And the takeoff weight is what? The sum of landing weight plus the trip fuel, and this should not exceed the maximum gross takeoff weight of the aircraft. That is very important. Now, if you see the distribution of aircraft weight, it is like this. So this is the aircraft type, that is your short range, medium range and long range. Right, if it is short range, operating empty weight will be 66% of the total weight, payload will be 24%, trip fuel will be 6%, and the fuel that is in reserve will be of 4%. So total 100% of the weight will happen here. Now coming to medium range, this is in the range of 59, 16, 21 and 4. If you see, the fuel is more. Range is the distance covered by your aircraft. Now suppose you go for long range, if you see here, the trip fuel is increased, but overall percentage will come up to your 100. So this is the distribution of your aircraft weight. So normally the fuel requirement of any aircraft can be divided into two categories. What are those? Your trip fuel and the fuel reserve. The trip fuel will depend upon how much is the payload, what is the altitude of travel, what is the speed of aircraft, distance that has to be covered or traveled, the atmosphere condition and all. And coming to the reserve fuel, it will depend upon the trip length, the traffic condition, the location of your alternate airports in the case of if there is any emergency landing and all, there it will be used. So the next one is your fuel spilling. So the spilling of fuel and lubricant is usually found in the loading apron and the hangars. So wherever loading apron is there and wherever hangars are there to repair your aircraft, there this spilling of fuel will takes place. So it is difficult to avoid your spilling completely, but efforts are made to bring it within certain minimum limit. So normally what will happen, the pavement or the bitumen material which is below these loading aprons and hangars will get seriously affected by the fuel spilling, and hence the area of bitumen pavement below the fuel inlets, the engines and the main loading gears are kept under constant watch by the airport authorities, and that will be renewed as and when required. So this is one of the characteristic that will influence the airport planning. Next, moving on to the next one is your jet blast, right? What is this jet blast? You can see in this figure, right? See here, this GIF is showing you the jet blast. Normally what will happen is whenever you have your turbo jet or your turbo propeller aircraft, this will eject very hot exhaustive gases, that too at a very relatively high speed or intensity, almost around 300 kmph speed. This hot exhaustive gases will be ejected. Now this might cause very inconvenience to the passenger who are boarding the aircraft, and as well as the surrounding area which is there in the aircraft. So for this purpose, several type of blast furnace are available, so that they serve as an effective measure for deviating this smoke or hot jet of air which is ejected by the engine onto a particular place. So it is desirable to provide a cement concrete pavement to resist this effect of jets. There is tendency that the bitumen will melt because of that high temperature or the speed of air jet. And also the effect of jet blast has to be studied in order to determine the size, position and location of gates. Okay, so to determine the size, location and position of gates, this jet blast should be studied. Normally where we are using these type of aircrafts only, this is required. Okay, the next one is your minimum circling radius. So a certain minimum radius in space is required for the aircraft to take smooth turn. Okay, so to take smooth turn, a minimum circling radius is required, and it will depend upon many things like your type of aircraft which you are using, right? The second one being your air traffic volume, the third one being your weather condition. Okay, so the knowledge of your minimum circling radius helps in separating two nearby airports by adequate distance, so that aircrafts which are landing simultaneous, suppose there are two aeroplanes or aircraft which are landing simultaneously, they will not interfere each other. In order to make sure that they don't interfere with each other, this minimum circling radius study has to be made. Suppose if it is not possible to provide such distance, what we have to do, we have to take care of the timings of landing and takeoff of each aircraft in each airport. We have to adjust it suitably. What will happen? This aspect will reduce what? Will reduce the capacity of each airport. Normally, we have to make sure that there is certain minimum circling radius, or else your airport cannot be used for its full capacity. So this table will show you the minimum circling radius for a particular type of aircraft. Suppose if it is a small general aviation aircraft under VFR, that is visual flight rule condition, we should have a minimum circling radius of about 1.6 kilometers. Right? If it is bigger aircrafts, say two piston engine under VFR condition 3.2, then also 1.6. For both this, it is 1.6 kilometers. Suppose we have piston engine aircrafts under IFR, that is the instrument flight rule condition, then we need to have 13 kilometers. And if you are using jet engine aircraft under IFR condition, we need to have a minimum of 80 kilometer circling radius. Understood? Next, getting into the next one, very important, is the minimum turning radius. So in order to know how much distance is required for turning of the aircraft, minimum turning radius is important. Normally this will help you to decide the radius of your taxiway and to ascertain its position in the landing apron and your hangars. Normally, what is the procedure we follow in finding the minimum turning radius is, we will first draw an axis from the nose gear. Okay, so this is your nose gear, right? We will draw the angle of turning of the nose gear. So this, if we are going for a turbojet, angle is between 50 to 60 degree. Normally this will be given by the manufacturer who is creating the aircraft. Okay, so first we will draw this. And then what we will do is we will draw the line through your axis of main gear. So this line we will draw next. Okay, so this is the first thing we will do, and this is the second thing we will do. After that, at 90 degree from this angle, we will draw a line drawn through axis of nose gear, right? And try to make it intersect through the line drawn through the main gear. So basically from nose gear line drawn through main gear line drawn, we will make them intersect at a point. Okay, so this is the path of your main gear. Right, now this is called as your center of rotation. Now from here we will take a distance of the maximum far end of the wing. Now if you take this, this is nearer distance. This wing end is at a nearer distance. So we will take a distance here, see here, like this. Okay, this would be the radius, you can say. From this you will draw a circle like in this direction. You will draw a circle, right? This is the minimum turning radius which we will get here. Anywhere you take, this will be the minimum turning radius. Also from this you can draw the path of your nose gear. When it is turning, your nose gear will move in this path shown, and your main gear will move in this path shown. This will move in this direction, and this will move in this direction. See, this is the path of your nose gear, and this is the path of your main gear. When turning, this is how it will move. Okay, so hope this is clear to you. This is very important in order to decide what the radius of taxiway, and also to ascertain its position in the landing aprons and hangars. Okay, moving on to the next one, the very important one which will come in your aircraft characteristic is the noise. So it is the main or the serious problem which is faced in the aviation, and we have to make sure that we get it to the minimum possible level. Okay, normally the main source of the noise is the engine and the machinery noise of the primary jet. Normally during takeoff, the main source of noise will be, or the primary source of the noise will be the engine, and during landing the primary source of your noise will be your machinery. So that's the reason normally taking off noise is more dangerous when compared to your landing noise. So the noise is measured by an instrument which is called as your sound level meter, and it indicates the total amount of sound present at any location. Normally it is described as the overall sound pressure level in decibel. So how is it described? Overall sound pressure level in decibels. Okay, so for complex noise such as those produced by the aircraft, the overall sound pressure level produces an inadequate physical description, and the two noise can have the same overall sound pressure level, and yet they may be judged differently or subjectively. Now it has led to the development of something called as preserved noise level intensity. Normally we will call it as PNDB. Okay, this is not so much feasible in case of your complex noises. That's why we have come up with something called PNDB, that is your preserved noise level. So this is the quantity that is calculated from the measured noise level and is adjusted by the weights more heavily that frequently will cause annoying or disturbance to the distances. Also, a further refinement of this has been done, and a new noise level called as your effective preserved noise level has come up. It is called EPNDB. Okay, so normally this is the corrected PNDB for the duration of the sound and adjusted for the presence of pure tone. Normally your aircraft certification happens based on this level only. Okay, and for the calculation of noise exposed forecast, that is your NEF. So the modern technologies has made it possible to dramatically increase thrust without significantly increasing the noise level, also to substantially reduce noise for a given amount of thrust. So the reduction in field length is also found to be most effective way for minimizing the impact of aircraft noise. So this is all about your noise characteristic. Next one is your range. So the distance that the aircraft can fly without refueling. Suppose once it is been refueled, until your next refuel, how much distance it can fly, that is called as your range. So distance that an aircraft can fly without refueling is known as your range. So there are number of factors that will influence the range of an aircraft, but the major factor is your payload. Usually as the range is decreased, so if you decrease your range, your payload will increase, and vice versa. Also, the relationship between this range and your payload is affected by many meteorological conditions during your flight. Okay, so then it is affected by the speed, then if it is affected by your fuel, wind, flight altitude, and the amount of reserve fuel which is there. So on all these factors, this relationship will be dependent on. Understood? Next one is the size of the aircraft. Right, there are many things which we have to take into consideration. The first one is your fuselage length. So this, or it is normally called as just your length of the aircraft. This will help you decide the widening of your taxiway on the curves and the size of apron and hangars that need to be there. The next one is your gear thread. So what is your gear thread? This. It is the distance between the main gear and it governs the minimum turning radius of the aircraft. So based on this distance between your main gear only, your minimum turning radius will be decided. Next one is the height of your aircraft. So this will decide the height of hangar gate and other miscellaneous installations inside the hangars. Then is your tail width. So you observe this is your tail width. Now this helps in deciding size of your parking and apron. Then is your wheelbase. Where is it? Here. So this is your wheelbase, front end, rear wheel distance, minimum radius of the taxiway. This will help you decide the minimum radius of the taxiway. Then is your wingspan. So what will it govern? It will govern the width of taxiway, clearance distance between two parallel traffic ways, size of apron and hangar, and the width of the hangar gates. So if you want to make a note of it, so this will help you decide what? Widening of taxiway on curves as well as size of apron and hangars. This on minimum turning radius. This for the height of hanger mainly. Right. This for size of parking and apron. Then wheelbase is for minimum radius of the taxiway. And the final one is your wingspan. This for width of taxiway and clearance distance between two parallel traffic way, that is distance between your two ways, and size of apron and hangers, width of hangers and gates. For all these things, this will be important. Okay, so if you see different aircrafts of different widths and different heights has been shown here in this particular picture. So this is why your size of aircraft is one of the important study which we have to make. Then moving on to the next one, the 11th one is the takeoff and landing distance. So this will help in determining the minimum runway length that is required. Okay, for minimum runway length, we have to do the study of your takeoff and landing distances. So the distance will depend upon many factors, right? So what are the important factors? Let us make a list of it. The first one is the altitude of your airport, where exactly, on which height your airport is there. It will depend upon that. Then your gradient of your runway, how much gradient are you giving for your runway, on that it will depend. The next one is the intensity and the direction of the wind that is flowing in your airport region, right? On that it will depend. Then the fourth one is the manner of landing, how, in what manner you are landing and taking off your aircraft, on that it will depend. Then on the temperature of that particular region, and finally the weight of your aircraft at the time of your landing and takeoff also will determine the takeoff and landing distances. Okay, so this accelerate stop distance. So start of roll, engine fails, thrust idle, brake spoiler, and here it is stopped. This much if it is there is a failure. Next is the type of propulsion. So the type of engine used in the aircraft has already been discussed. No, how many types are there, right? So the method of propulsion adopted for a particular aircraft will decide your size, speed, weight carrying capacity, noise nuisance, circling radius, etc. Everything based on your types of propeller, it will be affected, right? Next, and the last one is your tire pressure and contact area. Tire, can write it as TYRE also. So tire pressure and contact area. Normally this tire pressure and the wheel load will give an indication of the width, type and strength of pavement that is required for different types of aircraft. So basically we have to do this study in order to know what is the width, right? What is the type and strength of the pavement. Okay, so these are some of the aircraft characteristics that are very important. We have to study them and we have to see how they are influencing your airport planning. Hope it's clear to you now. Thank you.